Hello everyone, my name is Massinissa and my today's topic is Mobile One. Let's start the discussion of this presentation with a background of network security and its importance within the depth of Mobile One. The first question that must be answered or explained with the start of this presentation is, what is network security? Or we can say that, what roles does network security possesses in the modern world? Also, how it can be understood or defined to interpret or clarify its in-depth context. Considering the question above, network security is a broad term that covers a multitude of technologies, devices, and processes. It is basically a set of rules and configurations designed to protect the integrity, confidentiality, and accessibility of computer networks and data using both software and hardware technologies. Now, moving ahead, there are several threats to network security, such as phishing attacks, ransomware attacks, cryptojacking, or as fourth point, state-sponsored attacks. One framework of network security is firewall. Firewall monitors incoming and outgoing networks traffic and permits or blocks data packets based on a set of security rules. Its primary purpose is to establish a barrier between your internal network and incoming traffic from external sources. The example can be illustrated as the Internet, in order to block malicious traffic like viruses or hackers. Meanwhile, the above-mentioned network security threats play a major role toward network security attacks. However, its prevention and protection must be highly important. For this purpose, antivirus software play a critical role to overcome these threats in an effective manner. Hence, the ground reasons are: antivirus software helps protect your computer against malware and cybercriminals. Furthermore, it is essential given the array of constantly emerging cyber threats. One could be at serious risk of injecting a virus into his system or being targeted by other malicious softwares. It also remains undetected several times and causes havoc on your computer and mobile devices. This presentation would base upon researches of 5 different authors who explored and illustrated their viewpoints on the significance of network security within the depth of Mobile One. The first research paper that is analyzed in this research work is Big Mac, Fine-Grained Policy Analysis of Android Framework. This research paper elaborated Android attack surface, high-impact bugs, as well as Android security mechanism. The second research paper that will be explained is From Needs to Actions to Secure Apps, the effect of requirements and development and developer practices on app security. In this research survey, the survey concept will be clarified and explained with in-depth analysis. The third paper, which will be considered, is FANS, or Fuzzing Android Native System Services via Automated Interface Analysis. There are several challenges to this, which are as following. The challenge number 1, multi-level interface recognition. Challenge 2, interface model extractions. And the third challenge, semantically correct input generation. Moving forward, fourth research paper that will be considered is Chaperone Real-Time Looking and Loss Prevention for Smartphones. This paper, threat models and challenges will be briefly explained. Finally, The first and the last research paper reflects toward HTTPS everyone on the Android, or we are not there yet. However, this paper will demonstrate network security policy weaknesses, as well as the limitations of network security policy. Let's get started with the first paper. The motivation of first research can be summarized in these major factors. The first is Android attack surface. Here, the question arises, what is Android attack surface? Today, in modern world, there are a lot of attack surface on Android operating systems, whether it's via local applications or websites. Also, there are threats such as Wi-Fi, Bluetooth, or even physical attacks via USB. The second factor is high impact bugs. There are plenty of high impact bugs in the past, one of which was lipstick fright, which is a remotely triggerable MMS messages. The second is USB privilege escalation, and even a binder used after free vulnerability, which was triggerable from local applications. Meanwhile, the third factor is Android security mechanism. Threat model presents that is must be recognized what objects processes can be accessed based open the system policy. On the other hand, we have no processes in static firmware. And finally, whether the credentials and processes can be recovered from firmware. Within the Android security mechanisms, several technologies play a vital role toward primary access control, PAC. First one, Linux DAC. Second point, Linux capabilities. And as a third point, SE Linux or SE Android Mac are important. These are mandatory access control policies, and these three together formulate much of what Android security policy is. There are two others as well, SECCOMP, and the second one is Android middleware. But we are focusing on the first three as they interact together. The other major factor is Big Mac. The other major factor in Big Mac is session analysis of kernel. This slide emphasizes on the session analysis and its process. Furthermore, security policies for Android are spread out over the entire system on levels within files and within processes. The edit process is responsible for loading the mark policy into the kernel booting up the system and maintain securities for properties and other files on the system. It's a process, one of which is invented, assigns that policies to /dev also spawns Zygotes, which is managing all the applications on the system. It further spawns system server, which has its own policy files, and then also service manager, which manages native daemons. So all these together are a big part of Android security policy. But as an analyst, it's hard to reason about what the actual security policy is, because it's so spread out across many different systems. So this is where Big Mac comes in. What Big Mac does is to operate off Android firmware directly, and it extracts the core file system and then the files within them. From here, it extracts labels on these files. This includes the DAC and Mac labels, which allows to rebuild the graph and the interactions between different processes and objects on the system. This is held out by the SC Linux policy which is a tape graph, which allows us to understand the allowed relationships between different parts and different components on the system. Firstly, reflecting on the strength. SC Linux policy and backend files which are extracted allows us to create a subgraph, which is a very coarse-grained graph linking all the possible subjects in the system. This gives us a list of subjects, but we quickly translate them into a data flow graph, which instead of having fine-grained understanding of edges between subject poles, it's down to simple read-write relationship, which matches our privilege escalation model pretty well. Android boot process flow for the credential to be explicitly assigned to the services during the boot process. And even the boot time changes to the file system, such as file which wouldn't exist in the static firmware alone. Meanwhile, its weaknesses cannot be underestimated, and we are unaware of the processes that will be running on the firmware. We need to know the processes that will be running and then their permissions, so their credentials at runtime. The question which arises here is that, can we recover the processes from firmware alone? Yes, we can do. We can do through a partial emulation by simulation of Android boots. The first research paper of this presentation can be summarized as the following. Big Mac was created, one of the most fine-grained policy analysis framework for the Android device. Big Mac surpasses previous Mac-only policy analysis approaches through its layered path reduction. We highlighted Big Mac's ability to investigate escalation paths and examine the strength of processes. Moving on to the second research paper of this presentation, which explores the discoveries from a survey of Android and developments. The purpose of this survey was to investigate the security practices and the motivations adopted by these Android app developers. It is quite important to understand or interpret correctly what real software developers were doing by the way of secure programming and why they were doing it. In this motivation section, we came across to the conclusion regarding survey concept, adoption of insurance technique, GDPR changes, correlations found. At this particular point, one should understand the survey concept. The author of this paper have been scraping information from the Android App Store, Google Play for several years. From the Play Store metadata, they identify developer, contact emails, app installations counts, and the most recent update information. They also had copies of the applications themselves. Also, author identified the need to compare what the developers' addresses about that process in survey, which can be found out from analysis of the app binaries. The following figure illustrates the number which are observed, and a lot of testing validations were performed with 3 different kinds of pre-trial, all of which led to important changes. After the face-to-face pilots, it was realized that unsuccessful apps weren't interesting, so in the end, only those apps developed were invited with more than 100 downloads. Meanwhile, the limit time was also set to complete the survey, so anyone who just went through ticking randomly was removed. Due to some issues, some of the apps could not be downloaded, however, was enough for sensible statically analysis. The strengths that can be observed from the above-mentioned survey are Developer initiative requires substantial effort toward the need of securing apps. The next is GDPR requirements, which holds the importance around 45% when it comes to the need of securing apps. Moreover, management's decision is also an integral part in the process but holds only 21% effectively securing apps. Rest is the pressure from the customers or often the problems of media coverage within app security. The conclusion statement that can be summarized from the following paper is: less than a quarter of developers have access to security experts. GDPR has had very little impact. The second paper we'll further discuss is fuzzing Android native system services via automated interface analysis. Now, focusing on the background section of this paper, it illustrates that Android native system services provide many fundamental functionalities, such as: first one, gone mainly find system services vulnerabilities manually. Second point, Binder Cracker captures the input model through app traffic. Third, file system addresses the services by mutating the traffic. Fourth and last, it basically focuses on the vendor implemented Java services. However, the methodology that Android native system tends to adopt are: it randomly selects 10 interfaces, and it manually checks the interface models. The session analysis of this paper shows the communication model between application and service. So, in order to test Android native services system, we dig into the details of Android native season services. However, service will reject itself from the service manager and then listen to and handle requests from applications. On the other hand, application will require the service manager to obtain the interface or target service, which is denoted as top-level interface. Then the application can utilize the top-level service to retrieve multi-level interface or to call the other transactions to perform certain action further. Furthermore, application could retrieve multi-level interfaces and invoke corresponding transactions. The motivation within the paper can underline as: in order to solve the above-mentioned challenges, general-based fill-in solutions and funds are proposed. For instance, funds can be specially divided into 4 modules: interface collector, interface model extractor, dependency inferer, and fuzzing engine. Regarding the interface character, it is observed that services used on the transact method to dispatch transactions. According to this feature, we designed the following collection approach. And we compare AOSP and the recorded compilation commands. First, during compilation, interface-related files will be used. Second, now we can scan every C++ source file in compilation commands. And third, and seek for those files which contain the one transact pattern, so that we could collect all of the interfaces. The next, interface model extractor. It is observed that these are services used on transact method to dispatch transactions, and this process is usually implemented as a switched statement, so we can identify all transactions over target interface by analyzing the case node in the abstract syntax tree. On the other hand, dependency interface deals with the input and output variables extraction system. These services utilize special methods to deal with input and output variables. In variable patterns, Variables might locate in sequential conditional loop statement. Finally, the fuzzer engine refer to auxiliary information extractions, which tend to extract some auxiliary information such as transaction paths, which are separated by written experiment, or extract type definition, and finally, such as structure and union definition, enumeration definition. The significant threats or challenges that should be dealt effectively and efficiently are: Challenge 1, multi-level interface recognition. Challenge 2, interface model extraction. And challenge 3, semantically correct input generations. Let's have a look at challenge number 1, which is multi-level interface recognition. In addition to the top-level interfaces rejected in the service manager, there are nested multi-level interfaces, so we should collect all of the interfaces and the recognition multi-level interfaces. The second challenge, interface model extraction. To improve the funding effectiveness, the input data should follow grammatical requirements or target interfaces. So, doing so, we should extract the interface model that is needed to collect all the possible transactions and extract the input and output variable in the transactions changes to be. Challenge number 3, semantically correct input generations. We finally enjoyed native student service, which should generate semantic qualified input. There are many types of semantic requirements, including cloud name, which are as variable types. In addition, two dependencies are variable dependency and interface dependency. Therefore, the strengths that are identified with the context of this paper are interface statistics, extracted interface model statistics, completeness and precision, and finally, vulnerability discovery. Okay, this paper can be concluded as a systematical investigation of interface dependency, an approach to automatically extract interface model, a prototype of funds. Okay, now let's move to the third paper. In this session analysis, following factors will be discussed in brief: chaperone, smartphone laws, active acoustic sensing, and design of chaperone. A report which was released by Kaspersky Lab addressed that around 23,000 devices goes missing every month. However, the motivation for this paper can be underlined as smartphone loss is not rare in people's daily life, as in 2018, it was reported by Kaspersky Lab that about 23,000 Android devices were being lost every month. And smartphones are also the most commonly lost items in the Uber lost and phone index, as smartphones will result loss in both property and data. It also brings much inconvenience for it, since the smartphone is usually connected with many online services. On the other hand, firmware devices are a common solution to recover a lost smartphone. However, they highly rely on the network connections. They can be easily bypassed by turning on the airplane mode. Moreover, it is post-loss solution that takes effect only after the owner realizes the loss. Several strengths are being identified within this paper. First and foremost, prevention solution is preferred. On the prevention is Bluetooth device which can detect the owner who is far away based on the received signal strength, and other kind of solution is to use a special camera to sense the surroundings. For all the solutions, a common limitation is that they require additional hardware which is needed for smartphone loss prevention. for most commercial off-the-shelf devices. Furthermore, the acoustic sensing is a potential standalone solution, since all the smartphone devices have at least one microphone speaker. The basic idea is to send an acoustic signal and access its echo reflect by the target. The presentation of threat model within this presentation can be stated as chaperone defense against the nearby opportunistic attackers, and attackers can pick up the phone within several seconds after the owner's absence. It requires shape lane to detect the potential smartphone loss and alert the owner before it happens. Some assumptions are also needed to be made here. First toward acoustic sensing. Microphones and speakers of smartphone should not be accessed. The following algorithm assumes the closest person as the owner to initiate user tracking process. The methodology section of this paper can be discussed as. Accordingly, this figure represents the in-depth analysis and illustrates of design of chaperone. It shows that chaperone consists of 4 modules. Firstly, there is the trigger module, which decides whether to conduct accuracy signal. Other is acoustic sensing based on the context to save battery. It must be noted that acoustic sensing should be triggered only when it satisfies 2 conditions. The current location should be potentially insecure, unlike restaurants, and the phone is supposed to be stationary and not in use. Once all context conditions are satisfied, acoustic sensing modules start to send inaudible acoustic signals through a speaker, and microphone keeps recording all the time. The filters are usually applied to the receiver, applied to receive the audio data and match the audio signals, and then magnitude of echoes can be obtained from different distances. The next and third module is user tracking, which is responsible for obtaining the owner motion state. And finally, the decision-making model, which helps to determine whether it is a potential loss event. Challenges. Let's move to challenges. Challenge number 1, as it is observed as the main source arise from the environmental factors, which is high frequency noise. Chaperone uses an audible acoustic signal, which is resistant to audible noise like people chatting. However, high frequency noise that shares a similar frequency but many interface with the signal. The second challenge is when nearby people, while conducting acoustic sensing, a phone may reflect signals from people nearby to the hardware limit. Therefore, it is very hard to use the built-in speakers and microphones to track multiple people. So the critical problem here is how to focus on tracking the owner. And the third challenge comes from the environmental layout and obstacle static object. They both can reflect acoustic signals and block the signal transmission design. Okay, the following paper was quite extensive add-on to the knowledge, as it proposed a standalone real-time smartphone loss prevention solution and conducted extensive experiments to evaluate the detection performance and conducted a user study to obtain perceptual results. The future work that can be done on this topic is systematic study on specific environmental factors, long-term user study, and adaptive alert schemes. The last research paper of this presentation, within the session analysis section of this paper, methodology will be considered as the topmost priority. The importance of methodology can be identified to a number of reasons, which are network security policy weaknesses, large-scale analysis, ads ecosystem. Network security policy. It is a new defense mechanism that allows developer to configure through an XML configuration file to customize the network security settings without modifying app code. It is now impossible to completely forbid the clear text traffic from the application, implement certificate pinning strategies, and also handle additional custom certificate authorities without actually introducing any trust manager. It was first introduced in Android 6, then only the clear text feature was available, and it was significantly standard in Android 7 to support all the remaining features like clear text and custom transforms. Policy weaknesses. First weakness is clear text. Policy weaknesses were actually quite surprising to identify some results for work. Concerning clear text, they would identify that even though Google is trying to force the developer to adopt the HTTPS everywhere on their application. On the other hand, developers still act on the opposite ways, still sticking to HTTP. 67% of apps with network security policy were found that they still permit a network clear text connection. The second weakness is certificate pinning override. Since with these network security policies, it is very easy to implement valid certificate opinion strategies, but only 102 apps actually use this feature. Moreover, out of 102 apps, only 9 of them configure correct implementation. But at the same time, they shut down it with the overall pin output making the implementation of certificate pin setup useless. The third is silent man in the middle. Almost all apps that use a trust anchor configure it wrongly, and this means that this application potentially allows their SSL and TLS connections to be intercepted since they trust both the combination system user certificate index. Let's move to the threats. This section will undergo several vulnerabilities such as the developer doesn't know even the domain name nor the protocol that will be used by the library. This means that only available options for the developer is to configure a very open and potentially weak policy where it is not possible to forbid HTTP by default. Finally, the paper can be summarized as investigating the root causes leading to weak policies, observing that third-party libraries might encourage unsafe practices, designing and implementing a drop-in extension on the actual network security policy. With this, I have tried to go through all the papers, and now I only can say thank you very much for your attention.